Okay, hi class. So this is corresponding with the PowerPoint that can be found on day 10 for our lessons. We are looking at, right now we're working on composition of functions and inverse functions. So the first part will be this PowerPoint on on combining functions and composition functions, and then we'll move into inverse functions later. So the first thing I want to point out, we have a couple formulas, and all these formulas say is that if you take a function f and you take another function g, if you want to add them together, you simply add them together as f plus g, and then you can essentially combine like terms, and that new function is f of x plus g of x. And then similarly for subtraction, you're going to do f minus g. We're talking about this part right here, and so one important thing to remember about that is that since subtraction is not commutative like addition, you are going to have to um, make sure you put parentheses around whatever the second one is, because you're going to want to distribute that negative to both the other things. And I'll show you when I do the example down here. The next one that I'm talking about is going to be f times g. This is not to be confused with f of g of x or g of f of x. It's simply you take function f, you take function g, and you multiply them together, and you get a new function f times g of f. And then we have f divided by g of f, f divided by g of x. And we have the function f divided by the function g, where g is not equal to 0, obviously, because if g was equal to 0, this would be division by 0, and we can't have that under any circumstance. Okay, so we're looking at the example. It says given f of x is 3x minus 2 and g of x is 2x squared minus 4x, find the difference and the quotient of f of g, then find f minus g of 3. Okay, so let's go through f minus g. So if we take function f is 3x minus 2. So we're going to put 3x minus 2 and then minus g. So g turns out to be this one, so we have 2x squared minus 4x. Okay, so now we're going to distribute this negative to both of these, and we have 3x minus 2 minus 2x squared plus 4x, which turns into, we combine like terms, so we're going to combine this one and this one. And now we have minus 2x squared, it's gone. We have plus 4x plus 3x, that's plus 7x. And then we have a minus 2, and so minus 2. And so this new function is f plus g of x. Okay, if we go to the next example, we have f over g, or f divided by g of x. So if we do that, we have 3x minus 2 divided by 2x squared minus 4x. Well, if you remember up here, it said where g is not equal to 0. So if g is equal to if g of x is equal to 0, then simply when 2x squared minus 4x is equal to 0. And so that's when 2x squared, oh, I'm sorry, hold on, let me go back. I didn't notice they both have an x in them. So we're factoring the GCF right now. We have 2x, which factors from here and here. And then we have an x minus 2 left over, which means x cannot be equal to 0, and it cannot be equal to 2, because if it was 2, that would be 0, and if it was 0, that would be 0. Okay, and so this is our function, and we have x is simply not those two values. Okay, now for the last one, f minus g, we can plug in 3 into f minus g of x. So since we've already found this, we can use this equation that we got up here. And we have negative 2x squared plus 7x minus 2. I have done that incorrectly. Give me 1 second. Sorry. We have negative 2, and then we were going to plug in 3 for x, plus 7 times 3 minus 2, which is equal to negative 2 times 9 plus 21 minus 2, which is negative 18 plus 21 minus 2, which is simply just 1. Okay, and so f minus g of 3 is equal to 1. Okay, now that's combining them. Obviously, combining them, all you're going to do is you're going to add like terms and do things like that. Next, we're going to look at compositions. Compositions can be written as g of f of x, which is usually denoted GOF, which is sometimes people say goff, but you don't have to. And then obviously we can do f of g, fog. Sometimes you'll hear that. So you can even do f of x. That's another possibility. And then you can do g of g, and so on and so forth. You can basically compose any function that you'd like. To compose means to bring together or combine. I'm just reading the PowerPoint from up here right now. The composition function is a function within another function. Often one quantity is a function, is a function, and the second quantity that depends in turn on a third quantity. Example, the cost of a car is a function and of the gas consumed. The amount of gas consumed is a function of the number of miles driven. Knowing the distance you drove will allow you to find the amount of gas consumed. Then knowing the amount of gas consumed will allow you to find the cost of your trip, because obviously you have to know how much gas you need to buy, and gas prices vary. And so you can find the cost of your trip by knowing the distance you drove using a composition function. So of course x is the distance, and the machine g is the amount of gas as a function of distance. Okay, so then you'll have an amount of gas that you get, and then if you put that into the cost of the trip, obviously you can do the amount of gas times however many dollars per gallon the price of gas is, and that will give you the cost of the trip. Okay, and so if we look at the composition function, it is defined by f of g of x, f compose g, f of g of x. We're looking at this. Then if I said, so you guys can sort of ignore this. Actually, no, we'll just, instead of me writing it, I'll just highlight what we're looking at. We're looking, as of right now, we're going to read this. We have let f of x equal 2x plus 4 and g of x equal x squared minus 3x. Find f of g and then g of f. So if you want f of g, we can write it this way. That's how I typically write it. What we're doing is we're taking the function g and we're plugging it into f wherever we see x in f. So what that means is this is f, 2x, 2, this is what x used to be, but now it's g, we're replacing it with this. And then plus 4, and so plus 4. And so once we plug g, this is g, into f, which is, this is the template of f, we have 2 being distributed here. This is 2x squared, that's this. We have 2 being distributed to negative 3, that's negative 6x. And then plus 4, and since none of that combines, this is simply just f of g of x. Okay. Now similarly, we can do the same thing with g of f. We can use g as the template. And so notice in this case, g is x squared plus 3. And so when we go to fill in the template, we have the following. We have g being x squared. Well, x squared, we're just going to put parentheses, squared, minus 3 times x, which is another blank because we're going to put f wherever that x's are in g. And so then we will fill in these blanks with 2x plus 4 and 2x plus 4. And then we can simply go ahead and do our distribution and things like that. And you can see the steps to this right here. Combine like terms, and then you'll be on your way. Now, once you have g of f, okay, we can use that to find other values. So for instance, in this corner that you can see that they've done g of f of negative 2. And so when you have g of f of negative 2, you're going to plug negative 2 into g of f of x, wherever there's an x. And so they have simply just taken the 4x squared, put negative 2, plus 10x, which is still negative 2 in this case, because this is g of f of negative 2. and then they have the plus 4, and so this is 4 times 2, negative 2 squared is 4, plus 10 times negative 2 is negative 20, plus 4. 16 minus 20 plus 4 is equal to 0. And so that's g of f of negative 2 is equal to 0.